So before we start into what is being and yarn and all this stuff, so what are we doing? So we try to build a basically an application platform for validators so that we can let any developers to be able to write these applications. Because right now it's actually a really hard task to do. And in the course, we developed so one of the core execution engine that we have before Control. And it is actually a real-time stream processing system, similar to S4 and Storm. It has a tight integration with Hadoop and Meetup itself, so they can store it, transactions, lots of nice features, and there's like exactly one guarantee and all of those in it. And we like to run it with YARN. Better? Yeah, okay, great. So, let me repeat. So, we try to build an application platform to make any developers to be able to write their applications. So, in course, one of the products that we have is called MapReduce, which is a real-time streaming event processing system similar to S4 or Storm. But it has tighter integrations with storage, HBase, and Hadoop itself. And also have transaction support and only style transaction support and data integrations. So in the course, we try to run our workflow engine on top of YARN because we want to leverage an existing Hadoop process. The most common scenario is a lot of companies already have a Hadoop cluster being deployed. They want to use it, they want to maximize it, not just running MapReduce job. They want to run different kinds of flows, like real-time flows, or MPI, or even using it for load tests for different purposes. So this is how we start. So I believe everyone in this room pretty much know what is YARN. So YARN is basically the resource manager for Hadoop Cube, and it is actually much more than, but it is much less or more than MapReduce because it's the resource manager, so you can basically run any kind of distributed applications, which MapReduce is only one type of it. And it has all the goodies about Hadoop and large-scale cluster, and actually Yahoo, I think Yahoo is already using it in some of the system. So it is very nice. So we try to use it. But then we discovered that using YARN directly is very difficult. It is difficult in the way that the YARN is designed with the mindset of really functional rich, low-level API. So to use it to run some simple distributed applications, you have to write a lot of code. It's talking about 1,000 lines, 2,000 lines of code in that range. It's just for being able to run something. It's not about your application logic itself. And also there are some shortcomings about YARN is that it was originally built for applications that would terminate, like MapReduce. But what if you want to run a stream processing that would never terminate? So one drawback we see is you can never see the log until your job finishes. But if it's a long-running job, you never finish. You never see the logs. And how can you debug? How can you analyze the log? How do you see? How do you know what happened inside the application? That's one aspect of it. And also, it's because it's pretty low level, it's built as a very generic platform. So there's no application lifecycle management, or there's no complication generally defined between the application master, container, and those kind of stuff. That will be really useful for most of the distributed application. And in fact, what is a typical YARN application, distributed application looks like? Most of them are very simple, right? You want to start a bunch of services on a bunch of nodes, and then they will manage themselves in some way. Where they will start serving requests, they will start collecting logs, they will do their job. But you have to start and manage it and start it if any of it is time, right? That's pretty common, it's standard. So that's why it makes us think, what if we can run a distributed application as simple as running a Java thread, right? Because every Java program is pretty familiar with running Java thread. You implement the runnables, and then you create a thread to start it, or you submit it to an executor service, and then you can run it, right? So can we do the same? And at the same time, we try to identify like what are the common functionalities or like functionalities that are needed for distributed applications. So most of them we need like monitoring and restart of containers when it dies, loss collections, metrics collections in the distributed functions, but then you want to be able to see it and do it like in a centralized way. Of course, elastic scaling, which means without shutting down the application, we'll be able to provision more containers or reduce the number of containers we're running, depending on different criteria, right? And also, of course, we want to support all-run flops. That's one of our original idea why we want the things that we're building. And that's why we build Weave. So Weave is something that make the yarns in order, right? So the motivation of building Weave is, first of all, we're not going to replace yarn. So we're using yarn. We're trying to provide like a layer on top so that it's much easier to use, to run, to build distributed applications on yarn. And we hire lots of low-level details for yarn because we think, as I mentioned, most of the distributed applications is like following a very similar pattern. We try to hire lots of low-level details. Like we simplify the APIs for, I'll show you the APIs later, but we simplify the APIs for specifying, running, and managing applications, and have ways to manage the lifecycle of the applications. We also provide a generic application master so that you don't have to write a new application master every time you want to write a new applications that run on the yarn cluster. And also simplify like file management so that you can have a very simple API to submit your job and to run it. And also we have a central way to make the logs and errors handlings and metrics go back to being a very simple. So, I always talk about simplicity, right? So how simple it is. So on the left-hand side is examples that come with the vanilla yarn. This one is showing, I think it's like close-view. There are some newer versions that simplify a little bit, but still we're talking about like dozens of lines of code for running a distributed shell application. Which means a distributed shell application is basically you want to run a shell command across a bunch of containers. For example, AOS, or you want to find some files. Okay? And writing the same application using with the whole program is talking about like 50 lines of code. Doing exactly the same thing. So, what do we do? So this is how the architecture looks like. On the left, the green box is the things that you need. So basically, we have something called a Weave runnable, which is extended from runnable. So all you need is to implement your application as Weave runnable, and then you submit your application through a Weave runner, and that runner will basically look at your class, trace all the dependencies, package it, ship it, run it, start it on yarn with the application master, and the application master will base on the specification that you gave to the Weave run service to provision number of containers and then run the Weave runnable. And in between, there's a zookeeper for managing the life cycles between the life cycle of the applications, and also as a communication channel between the client and the application master, and also between the application master and the container, so that you can actually have a better control on the applications. And also in case like if your client dies and restart, you can actually have all the information being retrieved back from the zookeeper so that you can gain control of the application that is running. And we also use Kafka for the log collections. So the application master that we started will be run with a embedded Kafka by default. But actually you can turn that off, say if you have already have a Kafka that exists. But anyway, so by default it will run a Kafka embedded Kafka server, so that all the containers when it runs, all the logs and metrics will get collected through the Kafka server. And the client can have a way to look at all the logs in one place, rather than you don't have a way to look at the logs, or you have to access it to every single machine and figure out where the container is directly and look at the logs. So this is how the implementation looks like. So let's say you want to implement a echo server, okay, which is a very simple application. But let's say you want to run a bunch of echo servers across the customer. Okay? All you need to do is to have your class implement with runnable. You implement the run method, right? So in the run method, you can see it's present, it's just send the Java program, right? You start a service socket, you bind to it, you start listening, and then the weave also supports service discovery. So you can say, right now this echo service is on this host is listening on this wall. And then that's it, that's your application. Okay, it's talking about like, I don't know, 20 lines of code, even less. And so you have your runnable. So how to start it? To start it, there's something called weave runner or the weave runner service that you would say, I would like to prepare to start this echo service. So you just new the echo server. This code happened on the client side, okay? Which is the client submit job, right? And then you can say, you can actually configure this a little bit more. So the runner will expose a builder-like interface, so you can say prepare, and then I want to attach a log handler. So this one is pretty simple. It's just attach a log handler that will clean up the standard out of all the logs. And so on and so forth. So you can actually configure like resource specifications and also like a bunch of files that I want to make it localized in containers and so on and so forth. And then at the end, you say start. After you start, you get something called a weave controller, which is the things that you can control your application. So you can send commands to the applications, you can look at the status of the applications, you can like stop the applications, basically that's the piece for you to interact with the application. And in fact, in case if your client dies, you can also, when your client is start, you can use the weave runner to discover existing running applications and then get the weave controller for those as well. So the next one is, let's say you want to build a slightly more complicated applications which consists of more than one runnable. So for example, this case is like I want to start a web server in the YARN cluster, and also I want to start a log collector. So here and here, so I start a web server. So this one actually defines the application, contains a web server and a log collectors, and then you can specify like I have some files of a client box that I want to make it localized to the container. So this uses the localization mechanism that provided by YARN in a way that it basically will take your local files, upload the HFS, and then ask YARN to localize it, and then when the application shutdown, it will clean up the HFS as well. So it's pretty simple, straightforward way to define applications. Right. So after you define applications, you pretty much do the same. You have a weave runner. You say, I want to prepare this application. You can also configure it, and then yeah, it says well. And also, actually, we also support like ordering like, the starting sequence. So we are actually adding more features, but this is like I have multiple runnables, but I want to start that in a certain sequence. Okay, so we have like a bunch of things that we would like to add. So right now it is actually an open source project in GitHub, so anyone can check it out and download it and play with it and start using it. The current version works with the YARN 2.2.5. I know that YARN released 2.1, but they're working on to be like 2.1 compatible as well. And also there are a bunch of features that we're looking for, like we want to make the application master more generic and expandable in a way that you can actually have some custom logic in the application master to decide like what to do in case if container dies or a container finish, or you start it, or just like let it go, or what should you do. And also like more sophisticated logic in the application master to decide like when to start the container, when to start a new one. And we're looking for supporting more languages. So right now the whole API is Java. So you have to, we assume that you write your application in Java. That's the native language for Hadoop. But we're also looking for like supporting non-JVM languages. And then there are like a bunch of other stuff as well. Like for example, we are looking for contributors to start like HBase or web service or like Getty server or all the other stuff with as well. We are actually very interested in one of the work like starting HBase with. We know that there's some progress in the HBase community to try to run HBase on YARN, so we're actually interacting with those guys as well to see if we can use. And also have a way to programmatically control resource allocation, because right now the resource specification is pretty much static. You have to specify all of them when you submit it through the weblet. So we're looking for a more dynamic way. So for example, you detect that the loading is high, you might want to get more containers or you want to get a lot of containers or things like that as well. And also better UI and a bunch of stuff, better API, and also security. Because right now, so actually there's a ticket open in YARN talking about the supporting long-running jobs. So logging is one thing. The other thing is the security token. Because if it's long-running, then the HDFS security token will eventually get expired. Then when the job actually finishes, you actually cannot write block back to the HDFS file, which is what being done by YARN by default right now. So we are also working with the YARN guys to see how we can help as a whole to see because ultimately we want to make YARN be able to be easy to use and be able to run like any kind of distributed applications. So, so anyone interested, you can check out GitHub. It's GitHub.com/with. It's open source. You can fork it. You can just run it and see how it goes. And also we have very nice documentations with unity.com that you can look at. It has a very detailed tutorials how to start, how to use it. But it will be very, very easy to start for everyone that even have very minimal knowledge of YARN. And lastly, we are actually hiring. So if anyone thinks that is super excited, we're working on, Weave is only one of the open source projects that we're working on, and we're also working on real-time system. We're working on big data, security system, data system, application platform stuff. So yeah, so we are hiring actively. And the interest, talk to me, email to us. We're happy to talk to you. Questions?
Do we have any? Oh, sorry. Do we have any questions? Okay. Thank you. Okay, so our last speaker for today is Patrick Hunt. He's a major contributor and PMC member on the Apache Zookeeper project. He joined Cloudera more than 3 years ago and currently leads the Cloudera search team. Previous to Cloudera, he spent 5 years at Yahoo, where he specialized in large-scale distributed systems architecture. Welcome.
Thank you.